Today, we're diving into a feature in Engineering Equation Solver, or EES as you know it, that is an absolute lifesaver. Seriously, it's a simple little tool that once you start using it, you'll wonder how you ever got anything done without it. Let's jump right in. But first, let me ask you a quick question. Just think about all those times you've been staring at a calculation, and the result just feels off. You know that feeling. What do you think is the #1 absolute silent killer of engineering calculations? It's not usually some super complex formula or even a typo in a number. Nope, it's something way more basic.
Yup, unit errors. We've all been there, right? Mixing up feet and meters, pounds mass and pounds force. It is a universal pain that can lead to some, well, let's just say less than ideal outcomes. But the good news is EES has your back with a powerful, built-in safeguard against this exact problem.
See, EES has this secret weapon. It doesn't just crunch numbers blindly. It can actually understand the physical meaning behind them. By letting you assign units to every single variable, EES automatically checks your work. It's like having a little proofreader that lives inside the software, constantly making sure your equations are dimensionally consistent. And if it finds something weird, it flags it for you, which is an amazing first line of defense.
Okay, let's see this thing in action. We'll use a really simple example. Calculating the mass of a copper rod. Sounds easy, right? You just, find the volume, multiply it by the density, and bam, you're done. Or are you? As you're about to see, the real devil is hiding in the details, specifically in the units.
All right, so here are our givens. We've got a diameter of 2 inches, a length of 3 feet, and a density of 8.96 grams per cubic centimeter. See the trap? It's already set. We're mixing imperial units like inches and feet for the dimensions with metric units for the density. This is a classic setup for a unit nightmare.
Okay, so we've typed our equations into EES. We have the standard formula for the volume of a cylinder, and then the simple relationship that mass is just density times volume. We hit solve and we're expecting a nice, clean answer, but instead,
We get this. This little warning message pops up. Now here's the key. This is not a failure. This is a win. This is EES being our safety net. It's basically tapping us on the shoulder and saying, hey, I looked at your math, and your units don't really jive here. You might want to check that out. It spots the problem before it becomes a wrong answer we might accidentally trust.
And EES doesn't just leave you hanging. When you open up the Check Units window, it points you right to the scene of the crime. See? It's flagged our volume equation. And why? Because we're trying to multiply something in inches squared with something in feet, and EES is smart enough to know that doesn't just magically create a normal volume unit.
So how do we fix it? Well, the error message is a clue. It's telling us the problem is with our calculated variable, volume. We haven't told EES what kind of units we expect for it. We just need to define them, and thankfully, EES gives us a few ridiculously easy ways to do just that.
You've got 3 main options here. You can pop over to the Solutions window, find the variable v, and just right-click on it to set its units. Or you can use the variable palette right next to your Equations window. My personal favorite, though? Just hit the F9 key. That brings up the Variable Info window where you can see and edit everything all in one place.
okay, so let's say we tell EES the units for our volume are inches squared feet, just to make the equation consistent. And hey, it works. The error message vanishes. Problem solved, right? Well, maybe. Take a look at that result. What in the world is an inch squared foot? I mean, it's technically correct, I guess, but it's completely useless. We can do way better than this.
And this is where we level up. This is where we go from just fixing errors to actually mastering the units in EES. We don't just want an answer that's technically not wrong. We want a result that's meaningful, professional, and easy to understand. And for that, EES has one beautiful, incredibly simple function that makes it all possible. This is the transformation we're talking about. We're going from this messy, bizarre 217-inch squared feet to a clean, standard, professional-looking 10.2 liters. So how do we bridge that gap? The key is this magical little thing called the convert function. It's built right into EES, and its entire job is to find the right number to multiply by to get from one set of units to another, as long as they're both measuring the same thing, like volume. And the syntax couldn't be easier. It's just convert, then the unit you're starting from, comma, the unit you want to get to. Simple.
So here's how we put it to work. In our volume equation, we just multiply the whole thing by convert in squared to foot to liter. That's it. EES goes and finds that obscure conversion factor for us.
We do the exact same thing for our mass equation to get from that weird mix of grams, liters, and centimeters cubed into nice, clean kilograms. The result? A calculation that's not just right, but is also actually readable.
So let's just pull this all together. By using EES's own unit checking and conversion tools, we took a calculation that was a minefield of potential errors and made it totally robust. We didn't just get an answer, we got the right answer in the right units every single time.
And there it is. The final mass of our copper rod is 10.5 kilograms. A clear, unambiguous number that you could put in any report. And the best part? We did it all without ever leaving EES to go frantically Google a conversion factor.
So, why does all this matter? Well, for one, you're going to prevent so many fundamental errors right from the start. Two, when there is a problem, you'll debug it way faster because ES points you right to it. Three, you can communicate your results clearly and professionally, every single time. And four, you will save yourself so much time not having to hunt through textbooks and websites for conversion factors.
Look, by mastering this one simple feature, you're not just learning a software trick, you're adopting a workflow that makes your engineering work safer, faster, and just plain better. So, the question I'll leave you with is this. Now that you have this level of control over your units, what will you be able to build more confidently?